Okay, just two more bifurcations to discuss, the Pitchfork and the Hopf. So what happens in the Pitchfork bifurcation is that you imagine a curve of fixed points, and then out of them emerges another curve of fixed points. Okay, so this is x against mu again. Again, you would imagine that we're going from attracting, so eigenvalues in the left half plane, to in here then unstable, so that's one eigenvalue in the right half plane. Okay, so unstable, but what's happened is slightly different here in that you have emerging from that are two eigenvalues for values of the parameter greater than the value at which the bifurcation occurs. So here we've got, imagine fixing a value mu bigger than mu naught. So let me sort of imagine then we're looking at in this place here, this sort of mu value here. Sorry, I'll just draw that maybe a little bit better. So you're looking at that mu. If you imagine the dynamics in that, again, if we think in terms of the phase space, the dynamics is just in x, right? Then what would be happening in here is you would have these two. This would be a fixed point, this would be a fixed point, and this would be a fixed point. And that these two, which are bifurcated from this, would actually be attracting themselves, right? So this curve and this curve up here would correspond to an attracting case here. So this would be attracting. So bifurcating from an attracting fixed point are two attracting fixed points, and the old one then becomes unstable. This is called what's called a supercritical pitchfork bifurcation. A supercritical pitchfork bifurcation, because you can have subcritical pitchfork bifurcations where actually the bifurcating critical point fixed points bifurcate to the left, and they're not attracting, they're actually unstable. So then you get an attracting coexisting with two unstable, and then becoming after the bifurcation point just one unstable. So it's sort of the reverse situation, and that can happen too. And you have to look at the, you sort of algebraically expand the equations to see which one of those is. So the Hopf bifurcation structurally is rather similar to this, to the Pitchfork bifurcation, except you need sort of one extra dimension. This is x1, x2 now, and this is mu. So to draw it, you actually need an extra dimension. So imagine this is our curve of fixed points, and then there's a parameter value mu naught here, in which you have a bifurcation. But bifurcating out of it is not a critical point, but is a periodic orbit. Okay, so for each mu bigger than mu naught and close to mu naught, there will be a periodic orbit. So that means if I look at the phase space at a value mu bigger than mu naught, it will look in two dimensions, something like this. This is x1, x2. There will be this fixed point here. There will be this fixed point here, and then surrounding that will be a periodic orbit. And in fact, what happens if I look at trajectories in between, they spiral out to the periodic orbit. Those outside spiral into it. Okay, so that's kind of the situation that happens in a Hopf bifurcation. So we will see Hopf bifurcations a lot because these correspond to oscillations in the system. It's a way to identify oscillations in the system through seeing that there is a Hopf bifurcation. The structure that you have here is somewhat more complicated in terms of the spectrum, and it looks something like this. So what happens to the left here is that you have a spectrum like this. These are, say, attracting, okay? But it's these eigenvalues which are not real, which go through the axis. So over here, the situation is that these complex eigenvalues are the ones that have moved through. Okay, so I look at the Jacobian now. At one of these fixed points after the Hopf bifurcation, the eigenvalues are to the left. So at the Hopf bifurcation point here, what's happening in the Jacobian at the fixed point is that the eigenvalues are on the imaginary axis. And as you go through mu, right, this is mu going through mu naught. What's happening is the eigenvalues are going through the imaginary axis, and that's what indicates the Hopf bifurcation. Again, this